Problem 68. Consider the reversible reaction AB forms A plus B shown at two different temperatures, 200 and 400 degrees Celsius. Is the forward reaction endothermic or exothermic? So the A's are the blue ones, the B's are the red ones. Those are the products. And the reactant AB particles are the red and the blues attached together. Now we're shown the reaction mixture at two different temperatures. And temperature has something to do with heat. I'll just write heat and underline that. And we're asked a question regarding, what the reaction does under, endothermic or exothermic reactions. Remember, endothermic and exothermic reactions also involve heat. Okay, let's jump over to the right and see how we do this. First, let's remember that an endothermic reaction involves the reaction absorbing heat as it goes in the forward direction. And we can think of heat or energy, because heat is a form of energy transfer, as being a requirement for it to go forward. It's one of the reactants, so to say. When you have an endothermic reaction, it absorbs heat. Heat is a requirement for it to go forward. And so if you give it more heat, it's like you're giving it more reactant material and it will produce more products. So I'll write that over here on the side. More heat means you're giving it more of its reactant material and you're going to produce more product. So more heat means more product. Now let's look at the exothermic reaction. Exothermic reactions are opposite. The reaction releases heat. As it goes in the forward direction, heat or energy is one of its products. It's like a special type of product, okay? Different than the chemicals. So here it's the opposite case. Heat is one of the products. Now, what do you think would happen if you have a reaction which is exothermic and you feed it more heat? Okay, you give it more heat. Well, this time you're giving it more of the product material. It's kind of like if you're considering the reaction going backwards, okay, you're giving it more material that's required for it to go backwards. And so giving it more heat in this case would cause it to go backwards and form more reactant. You'd get less product and more reactant. So I'm going to put here for an exothermic reaction, if you give it more heat, you're giving it more of the material on this side, and that's going to help it go in the reverse direction. So I'll just say less product. Okay, now here is the key. So we got the key here and here. So we're shown the reaction mixture at two different temperatures, 200 degrees Celsius versus 400. Now 200 degrees Celsius, there's less heat, okay? It's at a less hot temperature. At 400 degrees Celsius, it's at a more of a hotter temperature. Now we've just been talking about what happens when the reaction is fed more heat, okay? For an endothermic reaction, there would be more product when it has more heat. In an exothermic reaction, there would be less product. So let's look at this one down here. Is there more product over here or less product? So I'm going to say, is there more product or less product? Let's see which one of these is the case. Okay, let's just count the product material. The products, remember, are the are the I'm sorry, are the blue and the red balls, okay? The ones that are attached together, those are the reactants. So here in this side, I count 1, 2, so 5 red ones and then 5 blue ones. That's 10 product particles over here. So I'll put 10 product particles. 10 products. And then what do we have on the right? 1, 2, 3, 4, 5, 6. There's only 6 product particles over there. So 6 products. And you can see by counting the number of product particles, at the hotter temperature, you have less products. So more heat is going to be less products. Okay, let's cancel that one out. More heat means less products. Well, that's the situation for an exothermic reaction. So the reaction is exothermic. So I'll kind of draw, this is the one. This is the case. It's exothermic.